yet another episode where we shall be looking at the different types of numbers, okay? So let me just wrap it up from this side, then we shall look at what exactly it all entails, okay? So we're saying types of numbers, okay? So initially, in our previous case, we used to look at the basic number types, okay? But now at our level now, we shall look at the number system as a whole, okay? So the number system is divided into two parts. So we have what we call the non-real numbers, okay? Non-real numbers. And then we also have what we call the real numbers. So the non-real numbers, at our level, we're just going to identify them. We're not necessarily gonna work with them, or we're not gonna use them. So the aim at this point is just to identify that, oh, this is a non-real number, okay? So examples of non-real numbers could be maybe the square root of negative numbers, okay? So when you punch this into the calculator, you get something like an error, okay? So it is an error because the calculators that we use at this point, mostly in high school, do not recognize the real number, the non-real number system, okay? But at higher levels of education, you find that we can find the answer to the square root of a negative number, okay? So these non-real numbers are sometimes called imaginary, okay? We just imagine them. So they're known as imaginary numbers, okay? Then the other one we said will be the real numbers. So throughout our school year, the numbers that we normally work with are the real numbers. So these real numbers are divided into two again, okay? One, let me just put it nicely. So we're saying the first one would be the rational, okay? And then the second one will be the irrational. Now, if I look at the rational numbers, we normally use letter Q for the rational numbers. And then this is irrational. We use a Q with a prime to represent irrational. So let's break down and see. So irrational numbers, we're saying these are numbers that can be expressed as A over B. In other words, they can be written in terms of fractions. Okay, we're gonna get back here. Irrational numbers, these are basically numbers that cannot be written as fractions. Okay, we're saying cannot be fractions, cannot be expressed as A over B or A over C, okay? So examples of irrational numbers, the common one is what we call the pi. And then from the pi, we can have the square root of all numbers that are not perfect squares. In other words, square root of numbers whose square root you cannot find to give you, let's say, a whole number, but you just get decimals that are endless. Let's say root of 5. Then we can also have the cube root of numbers that are not perfect cubes. An example, 9 is not a cube number. So the cube root of 9 must give us something that will be referred to as irrational. So examples of, let's say these numbers will be, for as long as you have a decimal that is not recurring, I mean, it's not repeating itself in any way. There is no pattern within the numbers that come after the comma. Those will be referred to as irrational. Then when it comes to rational, remember we have three aspects of the rational, okay? Number one, we have what we call the terminating fractions. Okay, 2, we have what we call the recurring fractions. Okay, these are just examples of rational numbers. These are recurring fractions. So if I'm to give examples, let's say for terminating fractions, we can have something like a 0.5. We can have a 0.75. Reason as to why we call it terminating is because it comes to an end. In other words, after the comma, the numbers after will be specified. In other words, there will be maybe 2 numbers or 3 numbers or 4 numbers. there's an end to the fraction. Then when it comes to recurring, these numbers just continuously repeat each other. An example, if you have 0.33333, which is always written as 0.3 with a dot on top. So these are the different types of examples of rational numbers we can look at. Other one could be the common fractions, which common fractions can basically combine these two. An example, if you have 1/2, which is the 0.5, 3/4 is 0.75, and so on and so forth, okay? Now, these rational numbers will be split down into 3 aspects. I'll just say one is the integers. Okay, integers, we normally use letter Z to represent the integers. Integers will be positive and negative numbers. Okay, an example, we can have -3, -2, -1, 0, 1, 2, and so on and so forth. Okay, so those are integers. Now, what we need to also remember is that integers do not have fractions in them, in as much as they have negative numbers, no fractions whatsoever. Okay, then from the integers, we can have what we call the whole numbers. Okay, so we know that integers will be whole numbers that are extended to the negatives. Okay, so positive and negative whole numbers. Then lastly, from the whole numbers, we can have what we call the natural numbers. Okay, so let me just give examples of this. So whole numbers are basically counting numbers, but they start from 0. So 0, 1, 2, 3, 4, 5, 6, and so on and so forth. Then the natural numbers, these are the normal counting numbers that start from 1, 2, 3, 4, 5, and so on and so up to infinity. Okay. Now the difference between the natural numbers and the whole numbers is just this 0. That is the only difference between those two types of numbers. Now, whole numbers will have a 0, natural numbers will not have any 0. Now, the letter for the whole numbers will be capital N with a 0, and then the symbol for the natural numbers will be just a capital N. So that's how these numbers can be broken down. So all we need to know is which type of number are we dealing with or are we talking about. Now, before I leave this, you will notice that all the numbers, especially the natural numbers, the whole numbers, the integers, they are all falling under what we call the rational numbers. So all these numbers automatically become rational because this whole number, let's say, can be expressed as a fraction, which will be something like 2/1. 4 can be expressed as a fraction, which is 4/1, and so on and so forth. So natural numbers, whole numbers, integers, all of them can be written as fractions, not forgetting the terminating as well as the recurring types. Okay, then one last thing that we need to remember is that if we have maybe a number over 0, we normally say that this will be undefined, okay? Anything over 0, for as long as the denominator is a 0, then we can say that that expression or that number is undefined. All right, so let's look at some worked examples and questions to deal with. Okay, here we have a question where they want us to classify, okay? The question is telling us to classify the following. Let's use this, okay? So classify the following numbers. So we can use a tick or we can just simply use a star or a cross. So let's look at 2. 2 is a normal number that we deal with. Ne? So 2 can either be non-real or real. So we choose one. So it's real. Is 2 irrational? No. 2 is rational. Why is 2 rational? Because 2 is a natural number. 2 is a whole number. 2 is an integer. So it becomes natural. So rational. Then 2 falls under the natural numbers. 2 also forms part of the whole numbers. 2 also forms part of the integers. So one number can be having more than one category. Okay, so all the categories need to be ticked, okay? Then next we have the cube root of -216. So what we need to do here, simplify this, okay? We know that the cube root of -216 gives us a -6. So it is this -6 that we shall be considering under the different properties, okay? So -6 is a number that is real, okay? It's a number because it's an integer, né? It's an integer because it's a negative. For as long as it's an integer, it becomes rational. -6, is it a natural number? No. Is it a whole number? No. So those are the only three boxes that we tick for this expression, okay? Then next we have 12,3 with a dot. So this dot on top here simply means that the 3 is repeating, which is 12,3, 3, 3, 3, 3. So we said for as long as we have a recurring fraction, automatically it becomes a rational number, okay? But rational numbers are part of the real numbers, okay? Do we have fractions under natural numbers? No, we don't have fractions under whole numbers. We don't have fractions under the integers. So it's just those two boxes. Next, we have √5, square root of 5. So when you punch this into the calculator, we know before even we punch that in, 4 is not a perfect square, okay? So for as long as 4 is not a perfect square, the answer we're going to get is going to be a very long answer. And if it's long, there's no pattern that's repeating to show the recurring format or what. So this √5 becomes irrational, okay? Then is it a real part? Yes. Irrational numbers are part of the real numbers. Then number cannot be rational and rational. It has to be one of them, okay? So we leave this. It cannot be a natural number. It cannot be a whole number. It cannot be an integer. Now someone ask why? We're talking about square root of 5. We are not talking about the 5. We're looking at the whole part. Lastly, we have 12 minus 18. So let's simplify this. This must give us a -6. So we're looking at the square root of a negative number. So we cannot find square root of a negative number at our level. So that will form part of the non-real numbers. So for as long as something is non-real, there is no other category that it can take on this side. So basically, that is how this first question would have been answered. Okay, so let's look at the other question. They are telling us that if we have this list of real numbers, okay, they have told us these numbers are real, we must use them to answer the questions that follow. All right, the first one, can we write down all the whole numbers? Whole numbers. Remember we said whole numbers, these are counting numbers that start from 0. There is a 0 here. Okay, so we have a 0. We have a 5. 5 is also a counting number. Is there any other? No. So those are the only two numbers for the whole numbers. Then irrational. So we said irrational. These cannot be written as fractions. Okay. We have a negative, but square root of 3. This is going to be an irrational number, regardless of the sign that's there. Then 2/3, this is a common fraction, which is rational. The rest are common, so we're going to say negative √3. And then one negative rational. So rational is one that can be written as a fraction, which is this one here, because they want the negative part. So -1 and then 1/2. So that's how we would have answered that. Don't worry about these others that have not been catered for. It's okay. Then question 2. If a of x, so this is more like a function. It's an expression or it's an equation. A of x is equivalent to the whole of this square root of 4x plus 1 over x. They want us to find the value of x such that a of x, when they talk of a of x, they are referring to this whole thing, okay, on the right-hand side. Value of x so that a of x is undefined. Remember we said for an expression to be undefined, the denominator must be a 0. And we're seeing that our denominator here is already x. So you're going to say that x must be a 0. Okay, find a value, find a value. So just a number, okay? Then for it to be non-real, okay, so for an expression to be non-real, what we said was whatever is under the square root must give us a negative, okay? So you can think of any number, but at this level, I'm going to think of different numbers. So what I'll do, I'll say 4x plus 1 should be less than 0. Less than 0 simply means negative, okay? When I move this one that side, 4x will be less than -1, and then x must be less than a quarter. So all the numbers that are less than a quarter. So in this case, even -2 could be fine. Even -3, -4, -5, all those numbers, because they are smaller than a quarter. You cannot put a 2 there or a +3 number, because it's just going to give us something that is real. So choose any numbers, okay, between that range. Then they want us to get a rational number. So a rational, remember, is where we can write it as a fraction. A over C, A over B, where A and C are integers. Okay, they are basically numbers. So what we're going to do is that we need the value of x that's going to make 4x plus 1 to be a perfect square. In other words, we should be able to find the square root of this entire thing that is under the brackets, okay? So if we use, let's say, a 2, if x is a 2, because that's going to be 4 times 2, that's 8 plus 1, which is a 9. We can find the square root of 9, okay? So then the whole thing will be a 3 over 2. So let's take x to be a 2. Remember they said find a value. So that's the easiest to go with, okay. Then question 3, they are telling us that we have these different numbers. We have 1 minus root 5. This is just one number. We have a 7, a 2 over 3, a 0, and then square root of -16 over 4. They want us to write down all the irrational numbers. Remember we said irrational numbers cannot be written as fractions. So the first one is a typical culprit. So 1 minus root of 5, because root 5, we know that is irrational. We can't find the square root of 5 easily, okay? We shall get decimals. Then part B, numbers that are non-real. For a number to be non-real, there has to be a negative within the square root sign. This is the culprit. If you simplify this, you get a square root of -4. So you're going to write the original expression that they gave us. Don't simplify it. So that becomes also our answer for that question. So that is how such questions would be asked. And that is how you would go about answering questions that deal with the different types of numbers, or that work with or deal with the number system. All right, so that is that in that regard. Okay, let's move on. How do we convert to a rational number? Now, from our previous discussion, we looked at the different types of rational numbers. Ne? We said these rational numbers are basically numbers that can be written in the form of A over C or A over B, where A and C are integers. Okay, but C should never be a 0, because if it's a 0, then the whole thing will be undefined. So we said we look at different types, which would be 1, the terminating rational numbers or terminating fractions. We say these common fractions of, let's say, 1 over 2, 3 over 4, 2 over 5, these ones that we can easily get the answers and come to an end. These are referred to as terminating fractions, because now this is 0,5, this is 0,75, and so on and so forth. So that becomes terminating, okay? How do we convert these terminating fractions into rational numbers? This is a bit easy. Eh? An example, if you have 0,5 and you want to move it back to 1 over 2, we look at how many numbers are there after the comma. It's just one number, or it's just one digit that's after the comma. So in this case, if I put a 1 over there, all I'll do, that we always do in grade 7, is that we multiply the numerator by 10, multiply the denominator by 10. By doing that, we're trying to move the comma to cover the 5. So it's going to be 5 over 10. When you simplify that, you get a half. If you had, let's say, 0,64, we do the same thing over 1. We have 2 digits after the comma. We multiply by 100. multiply by 100. Reason as to why we do that is that every step that the comma moves is just a multiple of 10. Okay, so it's just an exponent of 10. All right, so that's going to be 64 over 100. You can simplify this to 32 over 15, which will end up being 16 over 25, something like that. Okay, so that becomes a rational. So that is if you're dealing with the terminating fractions. Then when it comes to the recurring fractions, okay, the discussion kind of changes, because recurring fractions are basically numbers that repeat each other continuously. An example, if you have, let's say, 1 over 3, this could be the same as 0.33333, and so on and so forth, okay? Now, these recurring fractions could be written as a 0.3 with a dot on top. And you'll find that some books will also write it as a 0.3 with a line on top to show that the 3 is repeating itself. If we have two numbers that are repeating, let's say 0.14, and then they put the dots there, simply means 1 and 4 will be repeating, which is 0.141414. Then we could also have a scenario, maybe 0.16, and then the dot is just on the 6. This would be the same as 0.1 with a 6 repeating itself. Okay. And then lastly, what if we have something like 0.145, and then they just put the dots there and then on the 5. So automatically, all these 3 digits after the comma will be repeating each other. So 0.145, 145, and then 145. Now, the question is, how do we express these recurring numbers into common fractions? Okay, so we're going to discuss this. So for people that have not yet subscribed, please go ahead and subscribe so that you do not miss out on the interesting aspects that will be coming along, okay? So if I look at, let's just use these examples or these questions. They want us to convert 0.45 to a common fraction, okay? So 0.45, we have 2 dots there. But maybe before I even answer that, why don't we look at just one simple example with one number that is occurring? Let's use this 0.4 with a dot on top, okay? Let's assume this is what we must convert to a rational number. All right, so what we do, I'll say I'll let my k, any letter, be equivalent to 0.4. I will say 4 and 4. Let me just use 3 numbers after the comma, okay? Now, we're seeing that it is only one digit that is repeating itself. And if that is the case, I'll multiply either sides by 10. So it's going to be a 10k is equivalent to, the comma is going to move to the right. So I'll have 4 comma, keep the same number of decimals. Because remember, these 4s are continuous. They do not end. Let's call this equation number 2. Then we just have to subtract. Okay, I'll say equation number 2 minus equation number 1. So 10 minus 1, that's going to give me a 9k, and then 4 minus 0, that's going to give me a 4. These 4s will cancel the 4s, and then you shall have a 0, 0, 0, 0. So zeros after the comma will always have no effect or no value. Then let's divide both sides by 9. Okay, so which means our k becomes 4 over 9. So that becomes the rational aspect of this particular question. All right, then let's answer what the question gave us, the side of the 0.45. So if you have 0.45, which means we have 2 digits that are repeating, I'll let this expression to be equivalent to any letter. I'll use L, 0.45. Let me use 45 also, just 45 and then 45 continuous. This is equation 1. Then since it's 2 digits that are repeating, I'll multiply by 100. So 100L is equivalent to 45, 45, and then 45. So initially, if you had 4 numbers after the comma, you must keep the same numbers after the comma, even in the equations that follow. Let's call this equation number 2. And then we subtract equation 2 minus equation 1. So this is going to be 100 minus 1, which is going to be a 99L. 45 minus 0, which is going to be a 45. Then I can divide both sides by 99, then over 99. So that cancels that. And then I need to simplify this further. So which number can go into there? We can use 9. By 9 is a 5, by 9 is 11. So our answer becomes 5 over 11. So 5 over 11 should give us the 0.45, 45, 45, and 45 continuously. All right, next we have 0.1, 5 with a dot. Okay, let's see. 0.1, 5 with a dot. Okay, so it simply means that it's only the 5 that is recurring. So now the approach to this will be different. Okay, so I'll start by saying let maybe M be equivalent to 0.155. Yeah, it's fine. Let me have 3 numbers after the comma continuously. I'll call this equation 1. Then I'll start by covering the number that is not repeating, which is just 1 digit. So it's going to be a 10M is equivalent to 1, 5, 5, and 5. I'll call this equation number 2. Then it's time for me to cover the digit that is repeating. So for me to cover a digit that's repeating, I'm going to move 2 steps. So it's going to be 1 and 2. So from the original equation, I'll multiply it by 100. So that's going to be 100M. This is going to be 15, 5, 5, and 5. 3 numbers after the comma throughout. This is equation number 3. Then you go on and say equation number 3, we subtract equation number 2. 100 minus 10 is going to give us a 90. And then 15 minus 1 is going to give us a 14. These 5s will cancel out. Then what is left for me is to divide both sides by 90 and then over 90. So this cancels that. And then when we simplify this, we're going to get 7 over 45. And then that becomes our answer. Truly, 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 if you punch this 7 over 45 in the calculator, you should be able to get the 0.1555555. All right. Then we move on to question number 2. Okay. So consider the 2 numbers that are given. Okay. One number is the great pi, and then the other one is the 3,142. So all these 3 numbers are repeating. 142. Classify the respective numbers as real and non-real. So what we can see is that pi is a real number because we know that it works within the real number system, okay? 3,142, this is a fraction, which means it's also real. None of them is non-real. So both numbers are real. Then identify which number is further to the right on a number line. All right. So what you can notice is that this is a 3,142, 142, and so on and so on, okay? When you look at the pi, when you punch pi into the calculator, you're going to get a 3,1415, and so on and so forth, okay? So 1415, and then it continues, okay? So if you round it off, that's when you get the 3,142. So if you are to do a comparison, okay, of the numbers, there's a 3, there's a 3, there's a 1, there's a 1, a 4, and a 4, there's a 2 here, there's a 1 there. This is going to be the game changer, these 2 and the 1. So which means identify the number which is further to the right. So 3,142 is further to the right than the pi. In as much as the values are just close to each other, this one is more on the right. Okay, so write down the rational number. Which one is the rational? It is the 3,142 with those dots, because this is the number that we can express as a fraction. Then they're asking us to prove that the number chosen is actually rational. So this is where now we must convert this recurring fraction into a common fraction. So remember the routine, we said let any letter. Let's go visit y, okay? 3,142. I'll say 142. I'll call that equation 1. Three numbers are repeating, so that's going to be 1,000 y is equal to 3,142, 142, 142. Let's call this equation number 2. Then we do the subtraction, okay? So if subtraction is done, 1,000 minus 1, that's going to be 999y is equal to, let me just do this and see. If you subtract a 3, that's a 12, 9, 3, 1, 3. Is that true? Kind of, okay. So 3, 1, 3, 9. Okay, let's divide both sides by 999 and then by 999. So that cancels that. And then what is left is for us to simplify that. So please just punch that in the calculator and you get a simplified version of this answer. All right, so that is how this would have been approached. All right, so I'll leave it at that with this topic of converting numbers to a rational number. I mean, converting decimals into a rational number. All right. All right, welcome you guys back. We're going to be talking about rounding off, okay? So if it's your first time visiting and watching us, we thank you and appreciate your time. And please subscribe if you've not yet subscribed so that you do not miss out, okay, on more content that will be coming your way along, okay? So when you talk about rounding off, okay, in mathematics, it's just a form of approximation, okay? Another word for approximation is more like estimation. We're just giving a round figure, not exactly the same, okay? This is usually done for purposes of doing simple calculations and then, to ease our calculations and working with numbers, okay? Because it will be pointless for us to have a very long number that's having a whole lot of decimal places that we can't easily compute with the calculators. That's why we need to at least approximate or estimate them into something that we can easily work with, okay? Now, and there are certain things that we need to look out for. Number one, whenever you are rounding off, we need to look at the digits between 0 and 4 and understand that these digits do not affect those in the rounding position. So step number one, we need to identify the rounding position, okay? So rounding position is basically that position where you must round off to. If the question tells you must round off 2 decimal places, so the second decimal place becomes the rounding position. So our interest will be the numbers that come immediately after the rounding position. If they're between 0 and 4, they are not going to affect whatever is in the rounding position. And then if the digits are between 5 and 9, then they will increase the rounding position by just a 1. Let's give an example. Let's say we have something like 1, 2, 3, 4, 5, 6. Yeah, something like this. Then they ask us to round off this to 2 dp, 2 decimal places. Now, what we say is that start by identifying the rounding position. It's the second decimal place. So this is the first decimal place. This is the second decimal place. So this is our rounding position. Then the digit that's coming after 5 is a 6. So 6 is between that special category of 5 to 9, okay? 5 to 9, that's going to increase the rounding position by 1. So this 6 will add a 1 there. And then when you do your addition, it's going to be 1, 2, 3, 4, 5 plus 1 is a 6, okay? And then what was a 6 initially will just become a 0. We don't write zeros after comma, okay? In this case, since the question wanted us to give the answer to 2 decimals. Okay, if I have, let's say, what's that pi thing? Can have 3,1425. Then they wanted to one decimal place. Let's use one decimal place. So one number after the comma is this. Okay, one digit after the comma. So this is the rounding position. What comes after the one is a 4 automatically. So 4 is not going to affect this one. So which means the one will retain its status. So the answer for this will be 3, 1. All right, so let's see. Let's look at this question. So they want us to round off this to 3 decimal places. So it's 1, 2, and 3. So the 9 is in the third place. Then what follows 9 is 8. So 8 must affect the 9 by just adding a 1. So if you add a 1, that's going to be a 10. So it's a 0, you carry 1. 9 plus 1 is a 10, it's a 0, you carry 1. Then 0 plus 1 is going to be 1, 3. And then that becomes our answer. Remember we said zeros after comma will be useless. Ne? But if a question asks you to write to a given decimal places, if in those places there are no numbers, you have to indicate the zeros just to get to the question, to get to what the question was asking for. So 3,100 becomes our answer. Let's look at part B. We have 27,9235. They wanted 2 decimals. So this is 1, and then 2 decimals is here. Okay. What number follows 2 is a 3. So 3 is not going to affect the 2. So the 2 retains the status. So it's going to be just a 27,92. Okay. So whatever comes after that is just not written or indicated. All right. Then lastly, part C, if we have 189. Okay. 189,7512. They wanted to 1 decimal place. So 1 decimal place is the 7. After the 7, we have a 5. 5 will increase the 7 by 1. So that becomes 189,8. So this is approximately 189,8. This one is approximately 3,100. All right, so that is what happens when we are doing the rounding off. All right, cheers. Okay, then next we need to look at between which 2 integers does a surd lie. All right, so the first question should be, what is a surd? Okay, because that's what everyone will be wondering. What is a surd? What is a surd? So a surd is basically a number, okay, that is under a root sign. Number that is under a root sign. So it can be a square root, it can be a cube root, it can be a 4th root or a 5th root or whatever root it is. But for as long as we have a number and a root sign, it automatically becomes a surd. So what we need to remember is that these surds are usually irrational numbers, okay? Because we cannot find, let's say, the square root of 4 and the root sign. No. 4 cannot be under that because it can easily be simplified to just give us a 2, okay? So what we find under the root signs will be basically the irrational numbers, okay? So root of 2 is irrational, root of 5 is irrational, and then all of that. So the question is, between which 2 integers? Now remember, integers are positive and negative whole numbers, okay? That are specific. We don't usually want to work with the fractions under the integers. So how do we determine the integers, okay? Number one, we need to know that these integers must be consecutive. What consecutive simply means one after the other. They must be following one another. If let's say the smallest value is 2, which means the next value must be a 3. Number must be between 2 and 3. Number must be between maybe 4 and 5, between 7 and 8, something like that. The numbers should be next to each other. You cannot have 1 with a 2 as a minimum and then you have 7 as a maximum. No, these will not be consecutive integers. So the hints are telling us that we must use what we call the square numbers when dealing with the square roots. We use cube numbers when you're dealing with the cube roots, and then so on and so forth, depending on the root that you're being given. Is it a square root? Is it a cube root? Is it a 5th root or 7th root or whichever root it is, okay? Then after getting this, what are square numbers? Remember, if you square the natural numbers, 1 squared, 2 squared, 3 squared, 4 squared, whatever answers you get, those will be the square numbers like 1, 4, 9, 16, 25, 36, and so on. If it comes to the cube numbers, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on and so forth. So our focus must be on these numbers, okay? So how do we determine the answers? Okay, let's see. Between which two consecutive integers is the square root of 24 found on a number line? Okay, then I want us to draw a fully labeled number line to illustrate the answer. So what we do is, I don't need to punch that into the calculator now. All I need to look at will be, where do I find this 24? Between which two square numbers? So if I look at my square numbers, 24 must be falling within here, between 16 and 25. So I'll put a 16 there, I'll put a 25 there. And then next, I'll have to find the square root, okay, on either side. So square root there, and then square root there. We know that the square root of 16 is a 4, and then this is root 24 is less than square root of that is 5. So what this simply means is that if we use our calculators to determine the square root of 24, you find that the answer could start with a 4, okay? But then that answer will be smaller than 5. I don't know if I'm making sense. Okay, we said 4 and then smaller than 5. So we know that the square root of 24 is something like 4,898,9, and so on and so forth. We're not rounding off, we want the actual value. So this would be the approximated value, which is between 4 and 5. So it's bigger than 4, but then smaller than 5. So now if we are to represent this on a number line, okay, let's see how we draw the number line, okay? Just draw a line, not so long, not so short. Mark off a 4, and then mark off a 5. These are just inequality symbols with no equal signs, and then you connect that. So it's in between here, okay? Then part B, between which two integers does negative root 53 lie? You must show all the working details, okay? So let's do the same thing. Let's not worry about the 53 or the negative sign, but it's okay. Let me remove that negative sign. Let me start with the 53 straight away. So the question is going to be between which square numbers do I find the root of 53? Okay. So if I look at my square numbers from 25, we're going to go to 36. From 36, we have a 49. From 49, we have a 64. So you can say there is a 49 and then there's 64. So between those integers, between those square numbers. So you said 49 and then 64. It's fine. Then I'll indicate my square roots. So that's going to be square root of that is going to be 7. Square root of root 53, and then less than square root of 8. Now, when I introduce my negative, okay, so multiply through by the negative, so it's going to be a negative 7. The inequality symbol must change to greater. The negative root 53, and then greater negative 8. So when I look at the negative 7 and then the negative 8, we always start with a smaller integer and then end up with a bigger integer. So I'll have to rewrite this into negative 8 is less negative root 53, and then is less negative 7. And then this becomes my answer. All right. And then lastly, between which two integers does the cube root of 18 lie? So nothing different from what we discussed. Remember our cube numbers. The first one cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So you can see that 18 just falls between 8 and 27. So I'll start with 8 and then a 27, and then find the cube root, and then find the cube root there. So cube root of 8 is 2. And then this is going to be cube root of 18. Then cube root of that is 3. Then that becomes the answer of interest between 2 and 3. All right, so that is how we determine the consecutive integers where to find the irrational numbers. All right, let's talk about products. So from our previous class, we know that the word product simply means multiplication, okay? Now, under the multiplications, we use what we call the distributive property in most cases, because at our level, we need to look at the different properties or the different terms of the algebraic expressions. What we discussed previously was that we have different types of expressions. One, we have what we call a monomial. This is an expression with just one term. Okay. We have a binomial, which is an expression with just two terms. And then we have a trinomial, which is an expression with just three terms. We can even have a quadrinomial for 4 terms and so on and so forth. So under our products, we're saying if we have, let's say, x into maybe 2 plus y. So this x represents a monomial. And then this bracket represents a binomial because we have 2 terms inside. So from our law of our distributive property, we said whatever is outside of the brackets must affect everything that is within the brackets. So this x must multiply with a 2 to give us 2x. And then this x must multiply with a y to give us xy or yx. It's just the same thing, okay? So that's what we're going to be dealing with. So our first aspect should be to look at a monomial, a 1 term multiplied by a 2 term kind of expression, okay? So not to waste time, we said the negative 3y must multiply with a y. So that's going to give us negative 3y but squared. And then the negative 3y must multiply by 9. So a negative and a positive, we're going to get a negative, which must be 27 with a y. Now, these are not like terms, so we cannot simplify them. That becomes our answer. All right, let's look at part B. We have the 7x times 2. That's going to give us 14x. And then the 7x multiplied by the negative 3x. So this 7 is positive, this is a negative. So we're going to get a negative 21, but with x squared. Then this negative and the x is just negative x. The negative and the 2, we get a negative 2. Now let's look and identify any like terms. Okay, we're seeing that this x here is the like term with this one. These others are not having anything, okay? So it's going to be 14x minus x, which becomes 13x. Then that's minus 21x squared, and then minus 2. Now, how you represent the answer does not matter, for as long as the terms have their correct signs, okay? What I mean by that is somebody could say negative 21x squared minus 2 plus a 13x. It's just the same thing. It's correct for as long as the sign here is a negative and a negative. The sign here is a negative and negative. The sign in front of the 13x is a positive, and that is also a positive. So arrangement is not a big deal. Remember the properties of whole numbers, commutative and associative properties. Okay. And then 2, we have a binomial with a binomial. So in this case, we're going to use what we call the FOIL method. Okay, what does the word FOIL mean or stand for? So F stands for the first terms, no? And then O will be the outer terms, and then I will be the inner terms, and then L stands for the last terms. Okay, so let's see. If I have a plus c. I'm multiplying it by e plus d. Okay, simply means that this, okay, a times e is gonna be the f, because those are the first terms. Okay, then the outer terms will be this a times d. That's the O. And then C times E represents the inner terms, they are inside. And then C and D will represent the last term. So C is the last term of the first bracket, D is the last term of the second bracket. So just multiply that and then collect the like terms if you can, okay? So if I look at this, I'm gonna have x and x, that's gonna be x squared. And then x and 7, that's gonna give me 7x. And then negative 4 multiplied by x, it's gonna be negative 4x. And then negative 4 multiplied by 7, that gives us negative 28. Then what is left for us is to collect the like terms. So 7x minus 4x, that's gonna give us a 3x. Then we subtract 28. Then that becomes our answer because we don't have any like terms at that level, okay? So we love such questions, especially if it's a binomial and the binomial and there's a negative sign somewhere, because that negative sign usually kills people, okay? They usually forget it and they only consider the 5. So take the negative along. Let's look at the second one, 2x multiplied by x. And that's going to be 2x squared. And then we have 2x multiplied by negative 5. That's going to be negative 10x. And then we have a 3 multiplied by x. That's going to be a positive 3x. And then a 3 multiplied by negative 5. That becomes negative 15. This and this are like terms. So let's start with that. So 2x squared, negative 10, okay, with the sign in front, plus 3. That's going to give us negative 7x, then minus 15. So a number takes on a sign that is in front of it. I mean, you can only claim something if you can see it in front of you, not what is behind you. All right, then part C, where we have the fractions. We have a quarter x multiplied by 4x. That's going to be x squared. So we're saying a quarter x multiplied by 4x. So this 4 cancels that 4. You're just left with x squared. And then a quarter of x multiplied by negative 3 over 8. So 3 over 8, that's going to be negative 3 over 32. Okay, minus 3 over 32x. And then what is 2 times 4? That's going to be 8x. Then what is 2 multiplied by negative 3 over 8? That's going to be negative 3 over 4. And then I need to just collect the like terms. I need to collect the like terms there. So I'm dealing with fractions. So you could directly put that into your calculator and see what you get. What is 32 times 8? That's a 16-1. That's a 256. So 256, I subtracted 3. I'm going to be left with 253. Is that true? Yes. So it's going to be x squared minus 253 over 32x minus a 3 over 4. So that becomes our answer. All right, the next, we have a binomial multiplied by a trinomial. So I'm going to try to open this directly the way it is. I'm not going to do shortcuts, okay? Because if you know the difference of 2 cubes, there is sum of 2 cubes, you cannot re-summarize that up. But at our level, we've not discussed that yet. So let's see. So this y will affect everything in this bracket. So there are 2 ways of doing this that could have also been applied with a binomial and a binomial. So if I get a y, open this bracket, so it's 2y squared minus yx plus 4x squared. And then we have a negative 3x into the same thing, 2y squared minus yx plus 4x squared. So let me just open it the long way format. Okay, so y and that's gonna give me 2y squared. No, it's 2y cubed, not squared. Okay, so that's a 2y cubed. Then this y and that's gonna be negative y squared x, and then plus 4yx squared. This and that's gonna be negative 6xy squared, negative 3x and negative yx. I'm getting a positive 3 x squared y, a negative 3 and a positive, that's a negative 12 x cubed. All right, let's check if we have any like terms. So we have 2y cubed on its own. This is y squared x, and then y squared x, which is giving me a negative 7. Okay, negative 7 y squared x. And then this and that is giving me a positive 7 yx squared, and then minus 12x cubed. So this becomes our final answer. Okay, so there are no like terms here. This is a negative 7 y squared x. It's a 7 yx squared. Now remember, guys, that if we have x times y is xy, or it can be the same as yx. It's just the same thing. Okay, then part B. Part B. We have negative 1 over 3 and this whole thing. So I'll say negative 1 over 3 into a multiplied by a squared minus 3ab plus 9b squared. Okay, this is a plus 3b into that whole thing. So a squared minus 3ab plus 9b squared. Okay, so I'll keep the negative 1 over 3 out. Open that up, it's a cubed minus 3a squared b, because this a multiplied by that. And then plus a and that is going to be 9ab squared plus, then the 3b multiplied by that, I'll get 3a squared b. This and that's going to be minus 9ab squared. This and that's going to give us 27b cubed. Okay. Then let's cancel things out if we can see anything that needs to be canceled. So this is going to cancel that. This is going to cancel that. Then I can open up with a negative sign. So it's going to be negative 1 over 3a cubed. And then this negative multiplied by that is going to give me a plus, no, a negative 9b cubed. So that gives us the final answer. All right, then part C. Part C, we can do the same thing. A into a squared minus 2ab plus b squared minus b into a squared minus 2ab plus b squared, okay? Open this up, you'll have your a cubed minus 2a squared b plus ab squared. I'm sorry, my b looks like a 6. That's a squared b. Negative and negative gives us a positive 2ab squared, and then minus b cubed. Okay, let's see if we have any like terms. So a cubed, this one and that one will give us minus 3a squared b. Then this and this is a plus 3ab squared minus b cubed. Then that becomes our final answer. All right. If you have any questions, please feel free to slot them under the comment section. The next, we have factorization. Factorization. So some people write the factorization with S. Some books will write it with a Z, depending, okay? So they're telling us that factorization is the reverse of opening brackets. So in our previous lesson, we were opening brackets, or we're doing dots, okay? People call opening brackets dots. So the opposite or the reverse of the dots is what we refer to as factorization. We have a simple example here that if we have 2x multiplied by x, we're going to get 2x squared. 2x multiplied by 3, you get negative 6x. So if we move, okay, if we move from the left to the right, from here to there, we are expanding the brackets now, or we are opening the brackets using dots or products. And then if we move from the right to the left, we are factorizing. Okay, now we have different methods that we use when we are factorizing. Method number one is what we call the common terms. And at times, we use the change of sign under the common terms. So how does the common term work? So common terms, okay. Common term simply means that we're looking out for what is common, and then we take it out of the brackets. An example, if I have 4, and then I have 6, and then they ask me for what is common. If I use prime factorization, 4 can be written as a 2 by 2, and then 6 can be written as a 2 by 3. So what is common here? 2 is common. In other words, the number that can divide both of them will be a 2. All right, let me just go deep and say if I have a 4x squared and maybe a 6x, then I'm looking for what is common, because these are not like terms. So it's going to be 2 by 2, x, and then x. And then 2 by 3 by x. So 2 is common, but also we have one x that is common. So 2x becomes common, okay? So if a question was maybe 4x squared plus a 6x, and then they want you to factorize this, take out what is common, which is a 2x. What are you going to be left with? With the top, I have a 2, and then I have x that's left. So it's 2x. Plus, down here, I'm only left with a 3, so which is a plus 3. So we have factorized that. So if we try to open up this bracket, we should be able to go back to the original expression. So products and factorization are basically linked together. So that is how we carry out the common terms. Let's say we have something like maybe a y into 2x plus 1, and then minus t into 2x plus 1. We need to look for what is common. So you can see that this bracket and this bracket, they are common. So you take the bracket out, and then we shall be left with a y minus a t. And then that becomes our answer under the common terms. Now, how do we change the signs? Let's say we have a t into m minus 4 plus 2 into 4 minus m. So we only take out the sign only and only if we're seeing something unique amongst the brackets. Brackets must have the same things, but just in the opposite direction, opposite arrangement. So this is m minus 4, this is a 4 minus m. So what we do, we normally take out the negative sign. We don't take out any sign, but just the negative. So it's going to be t into m minus 4. If I take out the negative sign, then the sign in front of that bracket will change. That's a negative 2. And then the positioning there should also change to align to the original bracket. Then we can take out what is common, which is the m minus 4, shall be left with t minus 2. And then that becomes our answer by taking out the brackets. Now, what would happen if we had, let's say, a negative sign somewhere? I'll use y, and then x minus 2 minus 2 minus x. Yeah, beautiful. So this bracket and this, they are closely linked. So I'll have y into x minus 2. Take out the negative, then this negative sign will change to a positive, and then whatever is in the brackets will automatically switch. And then we shall have x minus 2 into, that's just a y plus 1. So if there's nothing in front there should be a 1 always. So that is just the first method of factorization. All right, then let's look at the second method of factorization. So we say the second method is the difference of two squares, okay? Just the word itself dictates, okay? That difference, what does the word difference in maths mean? Subtraction, okay? And then squares, these are basically numbers that are raised to the exponent of 2. So if you have x squared minus y squared, the way we factorize this is you open your two brackets, you find the square root of each individual term. Okay, so the square root of x squared is x. Square root of y is y. So this is going to be x and then y. So we put a plus, we put a minus. Done. Let's look at just some examples with numbers. Né? If we have 4m squared minus, let's say, n squared. So the square root of 4m squared is going to give us a 2m. Square root of n squared is just n. So 2m and n. So the brackets must have the same content. What differs is basically the sign. Doesn't matter which bracket will have the sign. This can have the negative sign, the other one can have the positive sign. It's not a big deal. Number 2, if you have 25k squared minus 9y squared, okay, square root of 25 is a 5. So that's going to be a 5k, and then square root of 9 is a 3. And then a 5k, and then a 3y. Can put a minus there, can put a plus there. We're done with the difference of two squares. All right, then lastly, what if we have something like 81 minus, let me use m to the 4. Something like this. Starting with a number to the exponent, something of the sort. So with this, for as long as the exponent is an even number, and then the other aspect or the other term or number, we can also find the square root. Then automatically the difference of two squares can be applied. So if I break this down, remember we said we're using square roots. Né? The square root of 81 is 9. The square root of m to the 4 is just going to be m squared. Then a 9 plus m squared. But if we look at the first bracket, it's still a difference of two squares. We break that down further, okay, into two brackets. So square root of 9 is a 3 plus square root of m squared is m. That's a 3 minus m, just for these two. And then this one cannot be factorized, so you keep that bracket. So we have factorized completely, or we have factorized fully, okay? Lastly, but not the least, what if I have k squared minus 1? What if we just have a 1 there? So just be informed that 1 squared is the same as 1. So which means that's a k plus 1 or a k minus 1. Something like that. So that is how we carry out the difference of two squares. Just very quick and smart, okay? Then we have the trinomials. So when you talk about the quadratic trinomial, we're talking about an expression that is having 3 terms, but the highest degree must be a 2. What do I mean? You have something like x squared plus bx plus c. We need to factorize something of this nature. So our point of interest will always be the product, okay? And also the sum. Talking about the product is if we have a and c, a multiplied by c will give us the product of the expression. And then b will represent the sum of the expression of the trinomial. An example, if we have x squared plus 5x just plus 6. Will that make sense? Yeah, it should. So there is a 1 in front of the x squared, which means our a is a 1. Okay, so 1 times 6 simply means that our product is a 6, but our sum is a 5. So what we do is that we look at the product. We look for numbers, okay, positive and negative, that we multiply to give us a 6. It can be 1 times 6, can be 2 times 6, negative 1 times, or It's 2 times 3, not 6. Okay, 2 times 3, -1 and -6, -2 and -3. Then from this, we need to get a pair that's going to give us a sum of a 5, which is just this pair of 2 and 3. Then come down, open your 2 brackets, tell us this is x with a positive 2, x with a positive 3. And then that becomes our answer. Okay, let's have another one. If we have x squared plus 7x, maybe plus 10. Yeah, something like that. So our product here is a 10. Our sum is a 7. Two numbers multiplied to give you 10 will be 5 and 2. 1 and 10, negative and negative, okay, so on and so forth. So I'm choosing these two because I'll get the sum of 7 and then a product of 10. Open, it's going to be x plus 5, and then x plus a 2. Then that becomes our answer. And then what happens if the a is not a 1? Okay, and then what also happens if you have a negative sign in between? So let me start with the negative sign, then I'll look at the a not being a 1. Okay, so we have x squared plus x minus 20. So our product is a negative 20. Our sum is a positive 1. So if a product is negative, simply means that one number must be positive, the other one must be a negative. So the quick one I'm going to go with is we have a negative 4 and 5. We have a negative 5 and 4. So the first option, I think it's going to give me a sum of 1. Then I'll come down and say, this is x with a negative 4. This is x with a positive 5. Okay, there we go. And then what's going to happen is if we have 2x squared, maybe plus 5x plus a 3. Let's keep it as that. Plus 5x plus a 3, where the a is a 2. You open your 2 brackets. What do we multiply to give us 2x squared? So that's 2x and x must give us that. And then what do we multiply to give us a 3? Positive 3 is going to be 1 and a 3. Where am I going to put the 3? Where am I going to put the 1? So that should be your try and error approach. If you put a 3 here, then you put a 1 here. Since everything is positive, then everything here should also be positive. Try opening up this bracket. That's 2x squared. That's going to be a 2x. This is going to be a 3x. Okay, then you get a 5x. And then we are done. We're good to go with this kind of thing. Okay, so which means that should be our answer. Let's switch it around and see. 2x squared minus 5x plus 3. Let's see. Remember the sum here is negative 5. And the product here is a positive 3. Will it even work? Will it work? Will it work? It might not. No, it will work, but now the signs are going to be negative and negative. Yeah? So it's 2x minus 3 and then x minus 1, because that is going to be negative 2x, negative 3x. Yeah, perfect. So that is how we would have gone about with the trinomials, okay? Then we have the grouping. Grouping works when you have more than 3 terms, okay? If you have more than 3 terms, then you'll have your grouping done. We shall look at some examples of, let's say, we have 2x squared plus 5x plus 3. Let me use that. 2x squared plus 5x plus 3. So the product here is going to be a 6, sum is a 5, which is 3 and 2. So if I have 2x squared plus 3x plus 2x plus a 3. Okay, remember what we said? Grouping, more than 3 terms. So if I have this as my question, all I'll do is put brackets around in 2 terms. So what's common here? It's x. Take it out. You'll have 2x plus a 3 plus 2x plus a 3. And then what's common? 2x plus 3 is common. When you take out this 2x plus 3, I'll be left with just x. Take that out, I have a 1. And then I'll have that as my final answer. All right, so that is to do with the grouping. Then the sum and the difference of two cubes should be our last method of factorization, okay? If you talk about the sum is addition, okay, of two cubes. This simply means if you have x cubed plus y cubed, this should be the same as x plus y, okay? You get the cube root of x cubed, the cube root of y cubed. That's what you get. And then we start squaring this, okay? So x squared is going to be x squared minus product of this and that. That's going to be xy, and then plus y squared. So this is the rule, or this is the format that we normally use when we are carrying out the sum of two cubes. And then let's talk about the difference of two cubes. Okay, if you have x cubed minus y cubed, okay, first bracket should have a minus. And then x, that is going to be x squared plus xy plus y squared. So you can notice that if it's a sum, first bracket is a plus, the middle term of the second bracket is a minus. If it's a difference, the first bracket is a minus, and then everything else is a plus. We can look at some examples. If you have 8x cubed plus 1, okay, so the cube root of 8 is 2, so that's going to be like 2x plus 1. In this bracket, the first term is squared, which is going to be 4x squared, minus this and that is going to give us 2x plus 1 squared, which is just the 1. That's our answer. If you have y cubed minus 27, cube root of y cubed is a y, cube root of 27 is a 3. And then you start with the squaring part. So that's y squared plus 3y plus the 3 squared is going to give us a 9. Then that becomes our answer. Okay, so guys, that is how we break down this factorization, these different methods, okay? So let's look at the applications and how we work out these things, okay? So number one, I want us to factorize the following expressions completely. So these are 4 terms. So what we said, just group them. Okay, where we have a minus sign should be within the brackets, and then put a plus sign outside. Okay, so from the first bracket, I can see x squared to be common, okay? Take out the x with the smallest exponent. So that's going to be x squared. I'll be left with x minus 6y. Down here, I'm seeing y being common, but there's also 2. Let me take out a negative 2y, okay? Negative 2y. And then if negative 2y is gone, I'll be left with a positive x. Then this sign will also change to a negative. 12 divided by 2, that's going to be a 6y. Reason as to why I took out the negative is because I wanted to create the same brackets. Remember, the first method was take out the common terms, or you can change the sign to create similarity. Now, what I can see is x minus 6 is common, okay? So x minus 6, take it out. I'll be left with x squared minus 2y. And then I'm done. So that should be a sweet 2 or 3 marks. Ne? Yes. Part B is a trinomial. With the trinomials, we say look for the product, look for the sum. The product is negative 30. And then our sum is just a 7. 2 numbers I multiply to give me 30, and then the sum is a 7, should be a 10 and a 3. Negative 3 and a 10. Okay, I think that's perfect. So open your 2 brackets, and then tell us x is a minus 3, x is a plus 10. And then that becomes our answer. Number 2, they want us to factorize completely. So still the same thing, brackets with a plus sign outside there. Okay, do we have anything common? It's not going to make sense if I just group them like that. Let me try to rearrange now because it's not working. So that's going to be 3xy minus x plus 2 minus 6y. Then let me group at this point. What's common here? X is common. I will have 3y minus 1. And then if I take out 2, I'll be left with 1 minus 3y. So rather, let me take out a negative 2 so that I have a 3y minus 1. So 3y minus 1 is common. What am I left with? I'm left with x minus 2. So that becomes my final answer. And then this part B, we have 8a cubed minus b cubed. So a difference of 2 cubes. So the cube root of that's going to be 2a minus b. Okay, 2a squared, that's going to be 4a squared plus 2ab plus b squared. That becomes our answer. And then here, with part C, what we're seeing is something unique, and it is very common, where different methods of factorization are combined, just like the previous questions we saw, that there is a change of sign, and then there's also taking out something that's common. Okay, so in this case, I'm seeing something common. This is 18, this is a 2. I need to take the 2 out if I can consider n squares. So if 2 comes out, I have a 9 minus m plus n squared. Okay, so that's a 2 into square root of 9 is 3 minus, we have m plus n, and then we have 3 plus m plus n. Okay, so that's a difference of 2 squares because 9 can be written as a square. That's why I've broken it down like that. So try to look at all the different methods, okay? Is it common factors? Is it a trinomial, a difference of 2 squares? Does it involve grouping, or it is the difference and the sum of 2 cubes? Okay, so that is that. Number 3. This is something that is already simplified for us. Let's take out what's common. So what I can see is that there is x here. There's also a bit of x. This bracket is common, a plus b and a plus b. So I'll take out x into a plus b. Then what I will be left with is that if this whole thing disappears, I'll have a 1 left. Minus, okay, I only removed x from here and the a plus b, which means I'm going to be left with 2x. And then this becomes our answer. When I look at part B, which is x squared minus x minus 12, okay, so my product is negative 12, and then my sum is negative 1. The two numbers of interest should be negative 4 and a positive 3, okay? If I open my two brackets, I'll have x minus 4, x plus 3, and that becomes the answer. Part C, 8x cubed plus 125y to the 6. So we can see that 8 is a cube number, x is raised to the exponent of 3, 125 is a cube number, and so on and so forth. So open your two brackets. The cube root of 8 is 2. Okay, that's 2x. Plus cube root of 5, cube root of 125 is going to be a 5. And then the cube root of y to the 6, divide this by 3, which means just going to give us y squared. Okay, what is 2x raised to the power of 2? That's going to be 4x squared minus 2x and 5y squared. That gives us 10x, but y squared. Plus, if we square this thing, 5 squared is a 25, y to the exponent of 4. And then that becomes our final answer. All right, then probably the last questions. If we have this kind of approach, we have 5x cubed plus 31x minus 28. Okay, so like we said, you can use this approach of the try and error. For me to get the 5x squared, I must have 5x, and then I must have x. For me to get 28, I can use 7 and 4. I can use 14 and 2. I can use, I think basically that is it. Or I can use 1 and 28. But I want one that is going to give me closest to that. So it's a negative. So one of them must be negative. Is a negative 4 or negative 7 and a 4. So if this is a 5, if I put a 7 here, and I put a 4 here. 5 times this is going to give me a 35. If I get 35 and a minus a 4, it's going to give me a 31. So minus and then plus. Okay, so that is one approach. Okay. Part B. I will not look at the second approach because it's going to be a bit lengthy. So let's group this because we have more than 3 terms, okay? Is it going to make sense? It should make sense though. Okay. Take out what is common. X is common in the first bracket. I'll have x minus 2. I have a 3y that's common. I'll have x minus 2. So x minus 2 is common. And then I'll be left with x plus 3y. All right, so that's become our answer. All right, so guys, that is that with the factorization. So it is one topic that is passable, okay? It's one section that is passable for as long as you only remember the different types or the different methods that can be used in the factorization. Okay, we're not going to tell you that, hey, please, can you use factors here? Hey, can you probably get the difference of 2 squares or what? You should be able to detect and see that. All right, guys, bye-bye for now. Okay. Now, when we look at the second part of the factorization, which is dealing with the fractions, okay? Fractions that will be involving factorization. So in this case, what we need to do is basically factorize where possible, okay? In other words, you need to activate the different methods of factorization. And then where we have plus signs in between the fractions, then you have to find the LCD or the LCM or apply the crisscross, okay? Here we go. Simplify the following, okay? So 5 minus 15x over 3x squared minus 10x plus 3 times, and so on and so forth. So before we even go there, remember if we have A over C times D over E, if it's a multiplication, numerators will be done separately and then denominators will be worked on separately. What if we had a division? Okay, so we need to change the sign to a multiplication. So A over C times, and then we switch this around, E over D, and then apply the multiplication again, C over D. Remember we said if we have a plus or minus, just do the crisscross, this, that, then that. And then you're good to go. All right, so let's work this out. Okay, these past exam papers and we see. So what's common here? We're seeing a 5 is common. I'll have 1 left minus a 3x over. When I factorize this, what do I multiply to give me a 3x squared? It's going to be a 3x and then x. What do I multiply to give me a 3? But this is a positive, this is a negative, so which means my answers must be a negative. So 3 and a 1. This and this is going to be a 9 and then 1. So minus, minus. Okay, so that's the first fraction. Then times. It's a trinomial. Numbers I multiply to give me 15 could be a 5 and a 3. Let me make the 3 negatives because when I add, I must get a positive 2. So that's going to be x plus 5 and then x minus 3. The bottom part is already factorized for us, which is x plus 5. All right. Is there anything that needs to be done? I guess there is, okay? But before I even go there, let me just cancel out what I see, that this x5 and x plus 5 is common. X minus 3 is also common. Now I can see that 1 minus 3x is more or less the same as 3x minus 1. If I take out the negative sign here, then the two fractions are going to be the same, okay? So I'm going to have negative 5 into 3x minus 1. over, this is the only thing left here, so I can put it that side. So negative 10 into 3x minus 1. So this cancels that. When I simplify that, I get a half. Oh, imagine this whole big thing just reducing to a half. All right, then part B. Part B, we have 9 minus x squared. That's 9 minus x squared over 5. We are dividing by 3x minus 9, but this is over a 15. So what do we see? Let's first change this to multiplication. 9 minus x squared over 5 times 15 over 3x minus 9. Okay, then let's do the factorization. This is a difference of two squares. So it's going to be 3 minus x and then 3 plus x. This is all over 5. Multiplied by, that's going to be 15 over what's common is a 3 into x minus 3. What I notice is that this x minus 3 and this 3 minus x, they share something in common. It's just a negative sign. So if I take out the negative sign, it's going to be negative x minus 3 into 3 plus x, or x plus 3, over what is 3 and 5? That's going to be 15 into x minus 3. This should also be a 15. No stress. So this cancels that. The 15 cancels the 15. So our answer is negative 3 minus x, or a negative with the same bracket x plus 3. So whichever way you want to put it, or in whichever steps you want to do it, that should be a sweet 4 to 5 marks. Then lastly, we have a squared plus 1 over a squared minus 1 plus, there's a plus. So whenever we have a plus, remember what we said? Crisscross. This and that, this and that, this and that. Crisscross, because it would be an issue if we have to find the LCM and so on. So crisscrossing will be easier. So what is this going to become? So I'll have a squared plus a multiplied by 5 plus 2a plus, will I have enough space there? It's not going to work, the space. So a squared plus a into 5 plus 2a plus, we have a squared minus 1. This plus is this original plus there, into 2a squared plus 3a minus 5. I'm dividing everything by the product there. A squared minus 1 into 5 plus 2a. Then I'll need to see if there are things that I can factorize, and then I'll do that. So from the numerator with the first term, I'll have a common, which is a plus 1. This is 2a plus 5, or just 5 plus 2a. And then plus, this is a difference of two squares, which means I have a minus 1, a plus 1. And then this is a trinomial, so which means I have two brackets. That's 2a. This is going to be a. For me to get negative 5, I need 1 and a 5, but one of them needs to be a negative. Let me make this a positive and negative. If I make this a negative 1, and this is a positive 5, will it make sense? 2a squared minus 2a plus 5a, perfect, beautiful. Then this is all over, okay? It's all over a squared minus, okay, I can say a minus 1, a plus 1 into 5 plus 2a. All right, then what's going to happen next is for me to take out what I think or what I feel is common. Okay, so with the first term, I can see a plus 1 and then the 5 plus 2a. A plus 1 to a plus 5. So these two brackets are common from the top. So let me just take this out and write it up there. All right, so we're saying a plus 1 together with the 2a plus 5 will be common. We are left with this a plus this entire thing, which is a minus 1 squared. Well, I can open this, or I can even leave it the way it is. But it's fine. Let me open it up. So that's going to be a squared minus 2a plus 1. I'm dividing this by a minus 1, a minus plus 1, and then 5 plus 2a. So this is going to cancel that. This is going to cancel that. And then we shall be left with that top thing and then the bottom thing. So if I simplify what is on top, I'll have a squared minus a plus 1 over a minus 1. And then this should be our answer. I mean, people must give us a lot of marks for this. Ne? I mean, we've worked hard. We have worked hard. So guys, that's how the fractions that are involving factorization are done, okay? So feel free to get quite a number of questions, practice. This thing is passable, okay? It is passable. We need all these marks. All right, then the next thing is exponents. So from previous grades, we've been talking about exponents and the laws and how they apply. So it's not different, okay, compared to what we're going to be discussing in this episode, okay? So let's start with the laws of exponents. Laws of exponents are more like principles that must guide our calculations when we are working with exponents, okay? Law number 1 is the multiplication law, whereby if we have something like, let's say, we have a 2x to the 5. Let's start from here. This 2 is known as a coefficient, okay? This x, since it's having a number on top of it, that x becomes a base, and then this 5 becomes the exponent of interest. So the combination of the exponent and the base is what we call the power, okay? So that will be known as the power. So the laws, we have the multiplication law that tells us if you're multiplying numbers with the same bases, you can as well add the exponents. Just quick, we want microwave stuff here. Okay, so x to the 10 multiplied by x to the 2, we just have x to the 10 plus 2, which is x to the 12. Then if you're dividing numbers with the same bases, we subtract. That's an example, quite there. And then if we have an exponent and then raised to another exponent, we just have to multiply the 2 exponents. There we go. So x to the 4 multiplied by 10, you get x to the 40. Okay? So we have m and q, which is mq. So this mq will affect the exponent of x. It will also affect the exponent on y. We can have those examples as well. Then law number 4, you have an exponent outside and you're multiplying or dividing. This exponent q will affect w. It will also affect the 12. So that you have wq and then 12q. So there we go, okay? And then what this 12 simply means that if you have numbers that are not prime numbers, you can break them down into prime numbers. An example, 12 can be written as 2 squared times a 3. And then you can raise it to whatever exponent you have and then apply the principle. Now, what we need to know is these laws are working in a two-way format. In that if you have x to the m times x to the n, giving you x to the m plus n. So it can work in this direction, but also if you're given this direction, you can also shift it back to that. What do I mean? If you have 2 to the x and then 2 to the 3, this would be the same as 2 to the x plus 3. So if this was given, you can always split it up to this format. We can see that under the applications, okay? So let's look at the definitions because we've seen these are laws, the first follows, and then the definitions could be an extension or the meanings of the certain aspects of the expanded laws. So x to the n, okay, so if a number is raised to the exponent of a certain number, let's say 5, we're just going to multiply that base the number of times that the exponent dictates, okay? The application is x to the 7. We have 7x's being multiplied. Any number to the exponent of 0 must always give us a 1, okay? So this is something that is very unique, that is interesting, especially when it comes to exponential equations and simplifications, okay? 5 to the 0 is a 1. A big number to the 0 must be a 1. This entire bracket with unknowns and what, for as long as it is raised to a 0, it's going to give us a 1. Remember, even if you have a 5, even if you have a 12, even if you have 18, we can get a 1 from all these things for as long as they are raised to the exponent of a 0. And then the other meaning is that if we have a negative exponent, okay, a to the negative n over 1. If we change this exponent to a negative, then the positioning must also change. Okay, something like that. So pay attention to all of this and what exactly is happening, okay? They are the examples that you can easily go over, okay? They are telling us the do's and the don'ts. So 2 is not the same as negative 1 over, is it 1 over 2? That's not the same. Pay attention to those basics, okay? Let's look at some applications or some calculations that involve exponents. Now, what we need to know is that whenever you're simplifying exponents, coefficients will be treated separately. And then bases must also be treated separately based on which law must apply. All right, so when I look at the first one, I can look at the numerator first. So 6 times 2, that's going to give us a 12. And then with the bases, x to the 3, x to the negative 4, that's going to give me x to the negative 1. Over, this is 8, x to the negative 3. Then I will divide 12 by 8. So by 4 is a 2, by 4 is a 3. So which means I'm going to have 3 over 2. Between negative 1 and negative 3, negative 1 is bigger. So since I'm dividing, I'll have to do the subtraction. So it's going to be negative 1 minus with a minus 3. So which means I will be left with just a 2. So x squared. This becomes my answer. Okay, so coefficients separately, and then the bases also separately. Now, we have 4 to the x minus 2 times 9 to the x plus 1, 3, and so on and so forth. What I need to do here is change these bases into what we call the prime factors. Prime factors will be like prime numbers, okay? We know that 4 can be written as 2 squared. 9 can be written as 3 squared. We said 12 can be written as 2 squared times a 3. So that's what we're going to do basically. Okay, so that's going to be 2 squared with x minus 2 multiplied by 3 squared into x plus 1 all over 3x minus 1 multiplied by 2 squared. So it means it's 2 into x minus 1 multiplied by 3 to the x minus 1. Something like that. Okay. There's a law that tells us that if you have 2 to the 3 times 3, everything is x to the 1. This affects everything inside. Then feel free to apply the laws now. We can say base of 3, base of 2, base of 3, base of 2. So let's apply the laws. The laws are simply telling us that if you're dividing numbers the same bases, you can do the subtraction. Yes. So I'm going to subtract the top parts. Or I can simplify them further and say 2. This is going to be 2x minus 4. I'm subtracting. Let's open this up. It's going to be 2x minus 2. Times. I have a 3. When I open that up, I have 2x plus 2 minus. This is x minus 1. This is also x minus 1. So it's 2 of them, which means it's 2x minus 2. And I simplify this, open up the brackets. It's going to be minus 2x, which is going to cancel this 2x. And it's going to be a plus 2, which means I have 2 to the negative 2. Someone will say, but how? 2x minus 4 minus 2x plus 2. This cancels this because of the opposite signs. Negative 4 plus 2 is a negative 2. Same applies here. This will cancel that. And then 3 to the 2 plus 2, which is 3 to the 4. And then let's change this because it has a negative exponent. So it's going to be 3 to the 4 over 2 squared, which is the same as 81 over 2. So that becomes our answer as well, okay? There are other options of splitting up. Other options of splitting up, which I don't really want to go into. Then with this part C, what do I see? What do I see? It's okay, let me just use the quickest approach ever. The quickest, I'll say 2 squared times 3 to the exponent of a plus 1. Let me take out this common exponent, and I'll have 2 squared times 3 to the exponent of 1. So I can see that the bases are the same. If the bases are the same, I'll subtract the exponents. We know that 2 squared times 3 is a 12. So it's going to be 12 a plus 1 over 12 to the a. Let's subtract 12a plus 1 minus a. You're just left with 12 to the 1, which is just the 12. Alternatively, you can bring in this, introduce that there, and then apply the laws straight away. You should be able to get to the same answer. All right, lastly, part D, we have 2 to the exponent of 3 into x plus 1. So that's going to be 2 to the 3x plus 1 over, this is square root. We know that square root of any number is the same as that number to the exponent of a half. Okay, so let's express 64 as a base of 2. So by 2 is going to be a 32. By 2 is going to be 16. By 2 is 8. By 2 is 4. By 2 is 2. 1, 2, 3, 4, 5, 6. Okay. So I'll have 2 to the 6x under the root sign. So we're going to divide this by 2. So 2 to the 3x plus 1 is the same as 2 to the 3x. You can do the subtraction, which is 3x plus 1 minus 3x. Our answer becomes just a plain. Why is it a plain 2? No. This is a 3. Hello, this is a 3, not a 1. 2 to the 3, which is 8. All right, so that is how we go about that, okay? Don't make the same mistake that I made of opening the brackets. Okay, guys, so that is to do with the exponents, né? So get the laws. After knowing the laws, we just need to know how we apply the laws, okay? Practice will always make perfect. All right, then let's talk about equations. And so equations are more like expressions that have equal signs, okay? Expressions with equal signs are what we call equations. We have different types of equations and their approaches will be different. Number one, we have what we call the linear equations. So under the linear equations, when we have to solve them, we always have to make the unknown the subject, which means the unknown should be left on one side of the equal signs. In cases where we have fractions, we've got to find the LCD and the LCM, especially if we are adding them. Adding or subtracting the fractions. We must use the LCM. Okay, so let's start with this. An example, if you're given x plus 5 is equal to 12, and we need to solve this. Remember, the degree of the expression here is a 1. So we need just one answer for as long as the equation is linear. Okay, let's have an example of some worked questions. We have root 24 plus root 96 minus root 600 is equal to x root 6. They want us to solve for x. So what we can do, let's break down this nicely. We know that 24 is the same as 6 times 4, which means this can be the same as 2 root 6. We know that 16 is the same as 6 times 6, okay, which means we're going to have a 4 root 6. And then 600 is going to be a 10 root 6 is equal to x root 6. So we can see that everything is having a root 6 within it, okay? Simplify them, no problem. So this is a 2 plus 4, which is a 6. Then 6 minus 10 is a negative 4. So on the left-hand side, I'm going to have negative 4 root of 6 is equal to x root of 6. Then divide both sides by root of 6. Root 6, root 6. This cancels that. So which means our x is negative 4. And there we go. Then part B, where we have fractions. Remember we said we can apply the LCD, okay, the LCD approach, or the crisscross. So we have 2x plus 1 over 6, 2x plus 1 over 6. Okay, then we have minus x minus 3 over 3 is equal to 2x plus 3 over 2. Okay, so whenever we have fractions like this and their equations, my advice would be eliminate the denominators. You can do that through the LCD. So this is a 6. I know that this is a 3 and a 2. If I multiply 3 and 2, it's going to give me a 6, which means the LCD is going to be a 6. Now, if you don't know how to determine the LCD, you can just multiply these numbers, 6 times 3 times 2, you will get a 36. You can still use the 36 the way we're going to use the 6 for you to obtain the same answer. So what needs to be done before you even start with the multiplication? Get to the numerators and put brackets around those numerators, okay? Then let's do the multiplication. So times 6, times 6, times 6. Reason as to why we are multiplying through by 6, we want to get rid of the denominators. So this 6 cancels that. By 3 is 1, by 3 is a 2. By 2 is a 1, by 2 is a 3. Then we open up. So 2x plus 1 is going to be a negative 2 multiplied by, that's going to be negative 2x. Negative 2 multiplied by negative 3, that's going to be a positive 6, is equal to 3 times 1, that's going to be, 3 times 2, that's going to be 6x. 3 by 3 is a 9. So this cancels that. Problem solved. 1 plus 6 is a 7, is equal to 6x plus 9. Let's move the 9 that side. That's going to give us a minus 2 is equal to 6x. So over 6 over 6. So which means x becomes just negative 1 over 3. There is no problem in getting your answer as a fraction, okay? Let's go down. We have 8x over 3 minus 3x over 2 should give us a 7. So still, we look at our denominators. We have a denominator of 3 and 2. Multiply them, you get 6. So let's multiply through by 6 to get rid of that. So by 6, by 6, by 6. By 3 is 1, by 3 is 2, by 2 is 1, by 2 is 3. So that's going to be 16x minus 9x must give us a 42. Subtract that, you have 7x is 42, divide both sides by 7. So which means our x becomes just a 6. Okay, so if you want to use the crisscross, yes, go ahead and use it and then multiply both sides by the denominator that you end up with. All right, so that is how we work out the linear equations, okay? Next, we have what we call the exponential equations. So exponential equations are basically equations that deal with exponents. So what needs to be done is that there is need for us to create what we call similar bases or similar exponents on both sides of the equal signs. But in most cases, our focus must be on the bases. Then in cases where we have a plus or a minus sign in between the bases, we shall have to apply the factorization. This is a note that if we have a base a to the x, then a base a to the k, then x must be the same as k. Then if we have p to the y and m to the y, p must be the same as m. So in other words, for as long as the exponents are the same, automatically the bases must also be the same. For as long as the exponents are different and the bases are the same, then automatically the exponents will automatically be the same. Let's solve the first question. We have to reach the x plus 1 is equal to 1. So number one, they told us we must create the same bases on either sides, okay? We have a base of 3, we have 1. Remember, under the laws of exponents, we said 1 can be expressed as multiple bases to the exponent of 0. So that's going to be 3 to the x plus 1 is equal to 3 to the 0. Drop the bases, which means x plus 1 is 0. Then x becomes negative 1. All right, so sweet, good marks there, okay? Same story will apply for the second one. So 5 2p must be equal to 5 to the 0. Drop the bases. 2p is a 0 when you divide both sides by 2, which means p is a 0. Then number 3, 3 to the 1 over p. Let's break down 81 to a base of 3. Said 81 divided by 3 is going to be a 27, by 3 is going to be a 9, by 3 is going to be a 3. So we have 4 of them. Drop the bases. So 1 over p is the same as 4. And then crisscross. 4p is a 1, which means p is going to be a quarter, 1 over 4. Lastly, we have 2 to the p plus 1 minus 2 to the p is equal to 8. Is this one. Okay, so there's something that we discussed under the exponents, and we said the laws can move backward and backward, forward and backward, sorry. So if you have 2 to the p times just a 2, it's the same as 2 to the p plus 1. Okay, this is law number 1. So instead of me leaving it like this, I can write this one so that I show people how the factorization is going to be done. So let's take out what is common, which is 2 to the p. Have 2 minus 1 is equal to 8. So we can see that 2 minus 1 is going to be a 1, which means I need to create the same base, which means it's going to be 2 to the 3. I drop the bases. Therefore, our P is a 3, then QED. That was quite easily done. All right, so that is what will be done under the exponential equations, and that is how we approach them, okay? Then we have the quadratic equations. So quadratic equations come from the quadratic expressions, okay? Remember, our expressions will be in the form of x squared plus bx plus c, okay? So we have something like that. You apply the rules of factorization. That is going to help us. So step number 1 is create a standard form. Standard form is where everything is on one side, and then we have a 0 left on the other side. We always give a mark for the standard form, okay? Then 2, you need to factorize. Find the appropriate method. Is it a difference of 2 squares? Is it common vectors? Is it a change of sign? Is it grouping? Is it a difference of sum of 2 cubes? Whichever one it is. And then we apply what we call the dot product. Dot product simply means that if we have 2 numbers, A times C giving us a 0, one of the numbers must be a 0 for us to get something like this. We don't know which one it is, so that's why we always say that either A is a 0 or C should be a 0. So let's say this A and C were brackets, then it will be those brackets will be equal to 0, and then we solve for the unknowns. All right, so look at the first one. We have 3x squared minus 5x. One thing I also need to caution, boys and girls, ladies and gentlemen, is that do not cancel things out. Because with this quadratic equation, the degree of the expression or the equation is 2, which means we need 2 answers, okay? If you cancel just one unknown out, you've killed one answer already, and you're going to lose out a mark. So what we're going to do here, let's push the 5x that side. So we have 3x squared minus 5x should give us a 0. Let's take out what is common, which is x. Then we have 3x minus 5 should give us a 0. And then we go to the dot product. Dot product is either this x is a 0 or this bracket, 3x minus 5, is a 0. And then let's solve this. So move the 5, then divide both sides by 3. So 3x is a 5, positive, and then x will be 5 over 3. So that's the first answer. That is the second answer. So we've applied the steps. This is the standard format. Now the factorization, and then the dot product. And then we get our answers. All right, then part B. Part B. Wow. What a question in part B. So serious. So serious. So we have x minus 7. X plus 2 is equal to 10. X minus 7, x plus 2 is equal to 10. Now, before I answer this, there's something that happens with the dot product. That if you have a plus 2, a minus 3 is equal to 0 straight away. We just have to switch these numbers and then we get our solutions. Only if we have a 0 there. If there is no 0, we've got to open up the brackets using the FOIL. Please, ne? Let's not get lazy. So x and x is going to be x squared. X and 2, that's going to be 2x. Negative 7 and x, it's going to be negative 7x. Okay. And the negative 7 and 2 is going to be negative 14. Let's move the 10 that side. And then we have a 0. We simplify this. Minus 5x minus 24 is a 0. So this is the standard form. Then it's a trinomial. So we can use the trinomial's product and sum. Two numbers are going to be 8 and 3. I'll make 8 negative. So it's going to be x minus 8. X plus 3 is going to be a 0. So which means x is 8 or x is negative 3. Then those are our answers of interest. All right. Let's look at part C. Let's look at C. So still, things are being moved around. So we need to bring order to this equation. There's going to be x squared minus 6x minus 27 is equal to 0. So our product is negative 27. And then our sum is a negative 6, this one. So do the factorization, look for your factors nicely. So it's going to be x minus 9 and maybe x plus 3. This will give us x as a 9. This bracket must give us x as a negative 3. And then those will be the two answers that they need. Lastly, 3x, x minus 2. Let's see. 3x, x minus 2 is equal to 9. Is it 9 or 7? It's a 9. So still, we cannot use dot product straight away. We need to open up the brackets. So that's going to be 3x squared minus 6x. Let me move the 9 as well. So minus 9 is a 0. What I notice is that there's a 3, 6, and 9. So 3 can divide, or 3 is common. So divide through. So if you have an equal sign, you don't need to factorize out. Just divide through by what is common. So that's going to be x squared minus 2x minus 3 is going to be a 0. So which means my product is a negative 3. My sum is a negative 2. For me to get x squared, it's going to be x and x. For me to get a 3, I have a 3 and a 1. So since I'm looking at a negative sum, which means the bracket with a bigger number should be negative. This should be a positive. Okay, then we apply the dot product, which means x plus 1 is a 0. or x minus 3 is a 0. So this is going to give us x being a -1 or x being a 3. And then those will be the solutions to our dearest questions. Okay, so that is to do with the quadratic equations. Then next we have the simultaneous equations. Now, the word simultaneous simply means that we're dealing with equations that have the same unknowns, okay? And the typical unknowns, let's say the x's will have the same value, and then the y's will have the same value, or the t's or the r's will have the same value. So equations that have the same values for fixed unknowns, okay? Now, when you're solving these simultaneous equations, we need to work with both equations together so that we can arrive at the different answers. So we have two methods that we normally use, okay? We have what we call the substitution method, and then we also have what we call the elimination method. All right, so let's see what we're gonna be dealing with. So I'm going to use just 3 examples to show us how we work around with these simultaneous equations. Yes, for one of the questions, I'll probably use both methods, and then you should be able to choose which is work-friendly with you guys. Okay, so the first question is x minus 2y. Okay, x minus 2y is equivalent to 3. And then 2x plus 4y, 2x plus 4y is giving us a 0. Okay. So now what we said, we have two methods, okay? Let me start with the elimination. I want to eliminate one of the unknowns, okay? So step number 1, I have to baptize these equations. Call it equation 1, and then call it equation number 2. So if, let's say, I want to eliminate x, I have to make sure that the coefficients are the same within the two equations. So I can create similarity using division or multiplication. An example, since I want to create similarity, let's say in the first equation, so that I have a coefficient of 2, since I want to eliminate x, I have to multiply the first equation by 2. So I'll say 2 multiplied by equation 1. And the equation is going to be 2x minus 4y is equal to 2 times 3. It's going to give us a 6. Okay, I can call this equation star or equation 3. Having obtained that, then I'm going to work with the equation 2 and equation 3. I'll do the subtraction. So 2x minus x is going to give me a 0. 4x minus 4y minus 4y, that's going to give me a positive 8y. And then 0 minus 6 is going to give me negative 6. And then I'll divide both sides by 8, then by 8. So my y, if I divide by 2, is going to give me negative 3 over 4. So this is the y value. Then for me to get the x value, I'll get this y value and substitute it in either the 12 equations. So either equation 1 or equation number 2. So if I use equation number 2, okay, we're saying substitute y into equation number 2. So I'm going to have 2x plus 4 multiplied by negative 3 over 4 should give us a 0. So this 4 is going to cancel that 4, which means my 2x is going to have the 3 move that side, then divide both sides by 2. X becomes 3 over 2. So just clinically work with the method that you want to deal with, okay? Step by step, you should be able to get to both answers. So let me use the other method and we see. So it's x minus 2y is 3. Okay. X minus 2y is a 3. 2x plus 4y is a 0. We said equation 1 and equation number 2. Now, with the second method, which is the substitution, is get one equation and make one of the unknowns the subject. So let's say in this case, I can easily make x the subject. Okay, or I can even use equation number 2, depending. So let me use equation number 1. As I'm saying, from 1, x is going to be 2y plus 3. I'll call this equation number 3. I'm moving this 2y to that other side. And then I have to substitute equation 3 into equation number 2. So where there is x, I will put that. So that's going to be 2 into 2y plus 3 plus a 4y should give us a 0. Let's open that up. So that's going to be a 4y plus 6 plus a 4y should be a 0. That's going to be 8y. Let's move the 6 that side. It's going to be a negative 6. Divide both sides by 8. So negative 6 over 8, which is a negative 3 over 4. Then get this y and replace it in equation 3. Okay, we're saying substitute y into equation 3. Then our x is going to be 2 multiplied by negative 3 over 4 plus 3. That's going to be negative 3 over 2 plus 3. That's going to be negative 3 over 2. No, that's going to be a 6. No, it's just going to be a positive 3 over 2. And then that's what we get. I think those are the same values we got. No? Yeah. So whichever format or whichever method you go with, we still appreciate. No? Number 2, question 2. 3x plus 4y is 4. 3x plus 4y is 4. 3x plus 4y is 4. And then we have x minus 2y. It's going to be a 3. So call that equation 1. Let's call that equation number 2. So if we want to eliminate, let's say, in this case, let's try to eliminate y. Yes, let's create similarity within the y. So this is a 4, and this is a 2. But the signs are different, okay? In the previous question, we saw that the signs were the same. We subtracted. So I'm going to say equation 2 times equation number 2, because I want to create a 4 here. So my second equation is going to be 2x minus 4y is equal to 6. I'll just rewrite the first equation, which is 3x plus 4y is equal to 4. Now, for as long as the signs of what you want to eliminate are different, you apply the addition. For as long as the signs that are the same of what you want to eliminate, you use subtraction. Okay, so 2x and 3x, that's going to be 5x is equal to 10. Divide both sides by 5, which means x becomes a 2. Then get these 2, punch it either in equation 1 or equation 2, where you see x. So that's going to be 3 times 2 plus 4y is equal to 4. So this is a 6. When the 6 goes that side, 4y is 4 minus 6. 4y is a negative 2. Then divide both sides by 4, which means y is negative a half. So guys, that's what we do in equation number 2. Let's look at the last equation. Last equation. We have 4x plus 3y is a 13. We have 7x minus 2y is equal to 1. So still equation 1. This is equation number 2. Depending on what you want to eliminate. In this case, I can go for x. Okay. So if I want to eliminate x, I can see that this is a 4, this is a 7. For me to create similarity, I can multiply this top part by 7, multiply the bottom part by 4. So 7 by 4 is going to be a 28x plus 7 by 3 is a 21y. Then 13 by 7, that's a 90. Is it a 91? Yes. Then down here, I have 28x minus 8y should just give me a 4. and then I'll subtract since the signs are the same for the x's, okay? So that cancels that, 28 minus 8, that's going to be a 29y. And then what's 91 minus 4? That's going to be 87. And then over 29, over 29. So my y becomes a 3. Okay, so that is the y. Then for me to get the x, just substitute that into the original. So it's 4x plus 3 times 3 is equal to 13. So substitute y into equation 1. So 4x plus 9, or it's 4x is equal to 13 minus 9. So 4x is 4. Divide both sides by 4, x must be a 1. So guys, that's how simultaneous equations can be solved. These are still marks that everyone should be able to obtain without any hassles. Practice, practice, and practice. Identify the method that is comfortable for you and then use that, okay? Do not confuse both methods. All right, then we have the linear inequalities, Now, we have different types of inequalities, especially with the symbols. Number one, we have this, which represents greater than. Okay, some people call it bigger than. And then there are people that know how to use the crocodile mouth, what, those things. Then we have this one that is less than. And then we also have a scenario where we have greater or equal to, less or equal to, okay? So these are the symbols that we're gonna be using under this aspect of the linear inequalities. So solving linear inequalities is not different from solving linear equations. I mean, we're gonna be using the same steps, the same aspects, the same approaches. The only difference is that within linear inequalities, we have what we call multiple solutions, okay? We have a number of answers that we cannot write down unless the question tells us to do that, okay? With the linear equations, we say they only get one answer. X is equal to this, Y is equal to that. In this case, we're gonna say X is greater than maybe 2. So all numbers that are greater than 2 are possible solutions for this particular expression or equations, okay? Now, we have the first case scenario where we have negative 2x minus 1 over 2 is less or equal to 3x plus 4. What is the question saying? Solve the inequalities, draw a number line for their solutions, okay? Now, I'll answer this question before I give a tip of what exactly could happen. So with the numerator, I can put a negative sign, okay? Get rid of the denominator. So I'll say times 2, times 2, times 2. So I'll have negative 2x plus 1 is less than 6x plus 8. I'll move this one this side. So negative 2x minus 6x, which is negative 8x. I can move this one to that side. Should be less than 7. Then I divide both sides by a negative number, which is negative 8. Now, whenever we divide inequalities with a negative or multiply with negative, the symbols will change to the opposite direction. So which means x is going to be greater or equal to negative 7 over 8. Now, if I'm to represent this using a number line, I can have my negative 7 over 8, and then I'll have a dot that is closed, and then it will be moving just in that case. So for such cases, they will tell us that x is an element of just real numbers, okay? It doesn't matter whether it's a fraction, whether it's a what, and so on and so forth. So that is how we would represent that. Then for the second one, where we have the unknown in the middle, do the same processes, okay, while keeping the unknown in the middle. So let's move the one that side, let's move the one that side. So it's gonna be 0 minus 1, which is a negative 1. Gonna be left with negative x over 3 is less or equal to 3 minus 1, which is a 2. Multiply through by negative 3. Okay, so if I multiply by -3, I'm going to get a 3. We say the symbol must change to just multiply by -3 is just x. Then by -3, you get a -6. And then they're telling us that 3 is greater than x, but x is greater or equal to -6. So switch this around and tell us that -6, they said x is greater or equal, which means that -6 is less or equal to x, which is also less than 3. Now, if I'm to draw a number line for this, it should be a -6 and a +3. With the -6, the dot is going to be shaded because of the equal signs, and then the 3 must be just open. And then it should be something like that. That should be our solution. And then the last one, -3x plus 7. -3x plus 7. They're telling us that it's greater or equal to 1. Greater or equal to 1. Let's move the 7 that side. -3x is greater or equal to -6. Let's divide through by -3. Okay, which means x must be less or equal to 2. Draw your number line. Let's have a 2 here, a dot that is shaded, and then we move the arrow to that direction. All right, so that is what happens with the linear inequalities. And then lastly, we have the literal equations. So literal equations are more like equations, but they mostly have unknowns. In other words, we must solve the unknowns so that we keep the unknowns. Numbers are involved, but we're not getting a specific answer to say it's a 2 or 3 or something like that as definite, okay? So the same methods that we follow in solving equations, the same thing that we follow in these literal equations, okay? The transposition of numbers, moving them from one side to another, dividing, square roots, and so on and so forth, okay? So with the first one, 3ax plus b is equal to c. They want us to make x the subject. Sometimes they will say solve for x, or they will say make x the subject. So let's move the b to that side. So 3ax is going to be c minus b. Divide by 3a, and then divide by 3a. That cancels that, which means our x is c minus b over 3a. That's our answer. In this case, we can open up the brackets if we have any brackets. Okay, it's your choice. Or you can just leave it, and then so it's y minus y1 is equal to m into x minus x1. Let's open it up. So y minus y1 is equal to mx minus mx1. Let's move the mx1 to that side. So y minus y1 minus, now it's going to be a plus mx1 is equal to mx. Let's divide both sides by m. This cancels that, which means our x is going to be y minus y1 plus mx1 over m. And then that becomes our final answer. And then next we have pi a is equal to pi radius squared. They want us to make r the subject. So since this is a product, we shall have to use division. So which means a over pi should be equal to r squared. Let's get the square root on either sides. So which means a is going to be the square root of a over pi. And then number 4, a is equal to p into 1 minus in. We must make I the subject. Open this up, no problem. So that's a 1, which is a p, and then minus pin. Let's switch this around. So pin should be the same as p minus a. Divide both sides by pn. So pn cancels that. So which means our I is going to be p minus a over pn. And then that becomes our answer. 5, we need to make e the subject. We need to make e the subject. So get rid of this square root by squaring both sides. Okay. To get the square root, I'll have c squared being equal to et over m. Let's cross multiply. So c squared m is equal to et, then divide both sides by t. Divide by t. So our answer becomes c squared m over t. And then lastly, we need to make pi the subject. I don't know, let's call this a. For us to get pi the subject, we're gonna take it out, factorize it. We have 2r squared h is equal to a. Then divide both sides by the bracket. So which means it's a over 2r plus 2r squared h. And then that becomes our answer. So guys, that's how we work with the literal equations. Just it's more like the same equations, but just transposing and moving things around. Yes. Thank you very much. Till we meet again. Bye-bye.